Hello learners, this is Vandana, Assistant Professor in Department of Computer Applications, SFA College for Women, Swagasi. Now, this video lecture is about error detection methods in computer networks. In networks, it must be able to transfer data from one device, that is source machine, to another machine with complete accuracy. But in reality, data can be corrupted during transmission. So, for reliable communication, errors in data must be detected and corrected. Generally, error detection and correction can be implemented either at the data link layer or the transport layer of the OSI model. There are three types of errors: single bit error, multiple bit error, burst error. Single bit error means only one bit in data will be changed. Here, the data sent by the sender is 0, 0, 0, 0, 0, 0, 1, 0. But the data is received as 0, 0, 0, 0, 1. So here only one bit is in error. So this is called a single bit error. Multiple bit error means the error will be in more than one data. So in this figure, there are that is error in 5 bits. 0, 0, 1, 0, 0 is transmitted as 1, 1, 0, 1, 1. This is called as multiple bit error. But this error is in consecutive bits. But if this error is not contiguous, then it is called as burst error. So அந்த error வந்து continuous இல்ல bitல அப்படினா அது வந்து burst error அப்படினு சொல்லி சொல்றோம். So in burst error, the length is calculated from the first corrupted bit to the last corrupted bit. So error detection means to decide whether the received data is correct or not. To detect error, we will use the concept of redundancy. Redundancy means we will add some extra bits in data to detect the errors. So redundancy means we will add extra bit data. We already said. So this is the data. In data, we will apply some generation function. Generation function in the sense we will generate one odd parity or even parity with the data. So with that parity bit, we will add the data. So sender will add the parity bits and the data to the receiver. On the receiving side, the receiver will check using the check function. If the check function satisfy means, then they will accept the data, otherwise they will reject the data. For redundancy, there are 4 methods: VRC, LRC, CRC, and then checksum. First we are going to see VRC. VRC means vertical redundancy check. In VRC, the parity bit will be added in each frame. In each frame we will add the parity bit. Here we will add even parity bit. So here our data is 1, 1, 0, 0, 0, 0, 1. Here the number of ones in the data is 3. While we will add another one means the number will be 4. So we will add 1 in parity bit. Suppose if number of ones in my data is 2 means we will add 0 in that parity bit. So this is called as VRC. So we will add parity bit to the data, and the data will be sent to the receiver as 1, 1, 1, 0, 0, 0, 0, 1. In the receiver side, they will count the number of ones. If it satisfies the even number means, then they will accept the data, otherwise they will reject the data. Then the next technique is LRC, longitudinal redundancy check. In longitudinal redundancy check, we will apply parity bit by using parallelly in all the frames. Here we will, for example, we taken 4 frames. In the 4 frames, first we are going to see MSB. MSB in first frame is 1, MSB in second frame is 0, in third frame is 1, fourth frame is 1. So while counting, that means there are 3 ones. So while adding 1 means the count will become 4. So MSB in LRC will be 1. Likewise, in each bit in each frame we will calculate the parity bit. So this is called as longitudinal redundancy check. This is the comparison figure for VRC and LRC. So VRC means the data will be added vertically. LRC means the data will be add longitudinally. So the data transfer will be in longitudinal. Next, the third method is CRC, cyclic redundancy check. So this is the most used method for the error detection. CRC is nothing but we are going to divide our data with some divisor, and then we will add the remainder with our data. So the data will be sent to the receiver as data plus that remainder. Then the receiver will divide that data by the same divisor used by the sender. If they get the remainder means, then the data is in error. If they didn't get the remainder means, then the successful receiving of data. This figure next. This is the figure. Here our data is 100100. Here the sender uses the divisor 1101. This is decided by the sender. They use the divisor 1101. They will divide the data by the divisor. Here the remainder is 1. Then the remainder will be added to our data and it will be sent to the receiver. To choose the divisor, the sender will use the polynomial. For example, x power 7 plus x power 5 plus x power 2 plus x power 1 means for the 7th bit we are going to put 1. For the 5th bit we are going to put 1. For the 2nd bit we are going to put 1. The remaining bit will be as 0. This is the example. There are totally 8 bits. So first 1 means 0th bit is 1. Next the x power 0 means first bit is 1. Next x power 2 means second bit is 1, third bit is 1. Then there is no x power 3 and x power 4, so that is filled as 0. Then x power 5 1. Then x power 6 no, so it is put as 0. X power 7, there is x power 7 in the polynomial, then it is set as 1. So this is the divisor, this is what the sender chooses the divisor. Next. So these are all the general standard polynomials used by the sender to choose the divisor: CRC 12, CRC 16, CRC ITU, CRC 32. So 12, 16, 32 are nothing but the highest number in the polynomial. Next. So the next fourth method is checksum. This is the most easy method for the error detection. So checksum means on the sender side, the sender will add all their data, and that sum is called as checksum. Then they will complement that sum, and then that will be sent to the receiver along with our data. Along with our data, sender will also send the checksum. Receiver will, while receiving the data, they will check the checksum. In the checksum, if there is all ones means that is once again they will add the data. If the addition result is all 1 means they will accept the data, otherwise they will reject the data. So these are all the error detection methods. Thank you.